We're going to be looking at some propositional logic definitions, which I can say that they are uh, they 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 are usually asked in tests. So this time you must know that it's not like SMTH012 where they don't ask you definitions, right? So for this lesson, as you can see, I've written the objective of this lesson that it's for us to understand the basic concept of propositional logic and truth values. So once we're able to understand this concept and we are able to compute all the truth values, then I can say that you are sure that you can get uh, more than 50% in a test, right? So I can say that if you understand what's happening in this slide, I believe that you already have 50% in that test. So when we look at the overview, so I just took this code. Remember, I took these notes from the study guide. So I just took this code also that says that pure mathematics is in its way the poetry of logical ideas. So what this code is saying is that after this session, you must be able to understand the logical ideas behind math, or you should be able to apply logic in its uh, entirely. So when we come to the objective, we will engage in the mathematical reasoning to read, comprehend, and to construct mathematical arguments. And the main goal is to understand how to construct correct mathematical arguments. So you must know that everything that is based on this chapter will be based in mathematical arguments or reasoning, or we can say logic, right? So the first definition that we come across is what we call a proposition. So a proposition is what defines a proposition is what defines uh, the statement that we're gonna be looking at, or is this statement true? Is this statement false? Remember, when it comes to a daily life thing, we realize that a person can only be true or false. They can't be both, right? You can't be true and also be false. So this is where a proposition comes in. Now we say that a proposition is a declarative sentence or a declarative statement that can be classified as true or false, but not both. So, and we're going to use letters to denote the propositions. So our propositions in this case are P, Q, R, and so on. You see right there. So these are the propositions. Whenever you see P, you see Q, you see R, just know that those are propositions. You see S, T, those are propositions. So the second one, we come to what we call a compound statement, right? A compound statement is just a way of joining. And when you say that we're combining something, compound, right? It's from those who are doing chemistry. I'm sure you should know what is compound, right? So we know that when it comes to a compound statement here, these are formed by combining two or more simple sentences, and we use connectives or logical operators to combine such sentences. Remember, these simple sentences we are talking about P, Q, R, these are propositions, right? So when we connect these propositions, we connect them using, let me do this. We connect these propositions using this. I'll just open, and then I give you an example of the proposition. So let's say I have a proposition P, then I have a connective. Let's say this connective is O. I connect that to Q. Now this is called a compound statement. We say right. And our connectives, these connectives we are talking about, or which is already this one, or not, if it then is this one, if and only if is this one, and is this one. You see, right? These are the connected. So they can also ask you in a test to say that give the connectives. So once you're able to give the connectives, you should know that this is what you're gonna be focusing on. So now, when we come to the next slide, let me erase this, then we go to the next slide. So you must know that a compound statement, these are statements that are formed by combining two or more simple sentences. And we're going to be using the connectives, and I've showed you what are connectives. or we're going to be using logical operators. These are also called logical operators to combine such sentences. So now we have what you call a conjunction, right? We have conjunction, we have disjunction, we have a negation. So these three are the main concepts that we're going to be focusing on. Then the last two will be looking at the compound, the conditional statements, which they focus on implication. Then we also focus on the double biconditional statements, which is double implication. So when it comes to the conjunction, you must know that a conjunction is and. You see right now. So if we let two statements P and Q be any two statements, then the compound statement P and Q is called a conjunction of the statement P and the statement Q. So this is called a conjunction of the statement P and the statement Q. So you must know for a conjunction statement, this is what I'm talking about. And this end, we're going to represent this as multiplication. You see, right? We'll represent this as multiplication. So you must know this. We're going to be representing that statement as multiplication. So now we come to an example of a conjunction. How do we compute a conjunction? So let's look at the truth table. So a truth table is just a table that we're gonna be using to represent our truth values. And you must know that we have three different types of outputs for these. The first output, which will be a tautology. The second output, which would be a contradiction. The third output, which would be a contingence, which we'll discuss about them when we go further, right? So now we come here, we say that the truth value of P and Q depends on the truth values of constituent statements P and Q. Note that P may be true or false, and for each of these, Q may be true or false. So there is a combination of four possibilities. So what we are saying is that since we have, since this can be true and it can be false, and also this one can be true and it can be false. So when we combine these two statements, we are going to have a possibility of a certain truth value. You said right. So now the question is, how do I know which values to write here, which values to write? So now what I can tell you is that you must know that the formula that we have here is this p to the n, 2 to the n. We're going to be using this formula to compute. This is the formula that we'll be using, right? This is the formula that we'll be using. We'll be using this formula 2 to the n. So n will be the number of statements. You see right now, this will be the number of statements. This will be the number of statements. So let's assume now that we have two statements, right? P and Q. When we check this, we have two statements, right? P and Q. We don't count the same statement twice, right? We count it once. Even if they wrote another P here, we take this as one. You see right now. So now we have two statements here, P and Q. It means that our formula will be 2 to the 2, which is equal to 4. And one thing I can tell you about truth tables of this chapter, right, is that we always start with a 1. You see, right? We should always start with a 2. So it's like this. It's like if I say a statement now, let's say I say that it is raining outside. Then what I mean is that uh, uh, it is, let's say it is not sun, right? Then I come to you and say it is raining. So what I mean by this statement when I say that it should always start with a true. If someone comes and say it is raining, you can't say they are wrong. All right. First, whatever that a person says, they are correct unless they are proven wrong, right? So if I say it's raining, for you to disagree, you must first go check if it's raining indeed. You said it. Then if it's not raining, you can come back and say you are wrong. So whenever you are writing truth tables, you must know here that this should always be true. Whenever it's a normal statement, right? Unless if it's a negation statement. So if it's a normal statements always start with a true. You said it. Normal statements always start with a true, and the negated statements always start with a false. You said right. Now I'm talking about the first value here. So They always start with a true and they always end with a false. So you must keep this in mind. So another thing now, let's say we have two statements and we got four here. What you do, remember the formula gives us the base two and we have two statements. It means that we must divide this into two. So we're going to, if we divide four into two, we're going to have two, two. And we know that our statements are supposed to start with a true, right? So will be true, this will be true, this will be false. It must always start with a true and it must always end with a false. So it means that this is going to be, this one tells us that we're going to have the first statement is going to have two truths first. You see, they have the first one, the second one. And then it's going to have two false statements. There's one, two false statements. And then after formulating the first statement, we come and divide this one. Now we divide these two into two again until we get one, right? We get one, 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 one. And we know this should start with a true and end with a false. You see right now? So after true, we're going to have false, true. This, you see, check this. Let's look at this branch. We know it should always start with a true and end with a false. It should always start with a true and end with a false. So already we know our values here. It's going to be, let me change the color here. So this we know it's going to be true, false, true, false, which is this. You see, true, false, true, false. Then I've formulated the next statement. So this is how we formulate two statements, right? So the truth values of two statements. So we must keep that in mind. Always starts with the true, ends with the false. So now since we have formulated those, we can come and say this. Let me say, I can say this. Now let's start to compute. Let's apply the conjunction. I said that this conjunction and will be represented by a multiplication, right? So one, when we compute this, we're going to say this: one times one is one. One times zero is zero. You say right now, zero times one is zero. Zero times zero is zero. So that's how we're going to compute it, the end statement. We're going to consider end as a multiplication. Instead of saying one and one and zero is zero, we're going to consider this end as a multiplication. We know that one times one is one. One times zero is zero. Zero times one is zero. Zero times zero is zero. We say right now. So now, now when we have this statement, now I want to show you this. I said that the truth value will always give us three possibilities. It will always give us a tautology. And a tautology, this is a statement that is always true. You said that I'm just gonna say always true, but you must write is a statement that is always true. Then we have a contradiction. Contradiction. This is a statement that is always false. This is a statement that is always false. Then lastly, we have what we call a contingent. This is neither true or false. We say right now, this is neither true or false. So when we look at this, the question is, how do you know we have tautology, a contradiction, or contingent? You check all these values. For them to be tautology, it should be 1, 1, 1, 1. You see right now on the final solution, all these vertical values. For them to be contradiction, it should be 0, 0, 0, 0. You see right? But since there's a mixture of these numbers, we have 1 and zeros. So it means that this is neither true or false. You see right? So the one for this would be neither true or false. So now we can go to disjunction. If you have a question, you can stop me, right? I can't see comment sections. So if you comment something in the comment section, I'm sure you can see that the only thing I can see is this slide, right? You are also seeing it as well. So now another thing that I can say, right? I can say that for conjunction, For this to be true, for this statement to be true, both the statements should be true. You see right there. You see even here, the only way we can get one on conjunction is when Q is one, Q is one. So for this statement to be true, it's when these two statements are true. So we get it to be true. So we must always remember that. Now we come to this definition of disjunction. We say that if we let P and Q be two statements, or be any two statements, then the compound statement P or Q is called a disjunction of the statement P and statement Q, right? Then we can denote this by what? By P or Q. So now, since we know that we can denote this as P or Q, we must know also that we're going to represent this one by plus. So whenever we're computing, we'll just say plus, 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 right? And for this statement to be true, at least one of the statements between P and Q must be true. You see? So now let's come to a truth table, and then we see. And then for the truth table of disjunction, we say that the truth value of this P or Q also depends on the truth values of constituent statements P and Q. So when we say these are constituent statements, we are saying that these are statements that are contributing to this truth value right now. So we can illustrate the truth table of P or Q as follows. So remember how we write 1, 1. So for two statements, these are always going to be the same, these numbers. Even though I don't want you to crime, right? I'll show you how do you find these numbers. So this should be 1, 1, 0, 0. But we're going to do it again. Remember, we have two statements. So it's going to be 2 to the 2. Remember, this is 2 to the n, and n stands for the number of statements. So this is 2 to the 2, which this gives us 4. And I said, remember, we have two statements, right? So we're going to divide this into 2, 2. And we know that the first statement should start with a true, the second statement should start with a false. So we know that here we're going to have two truths, two false, right? Then we come to divide this into 1, 1. And this is a branch, right, on its own. This is also a branch on its own. We know that if we consider this branch, this must always start with a true, it must end with a false. Start with a true, end with a false. So we're going to have true, false, true, false, which is this, right? True, false, true, false. We agree, right? Then, so I'm going to, every time I'm having a truth table, I'm going to explain this so that you can know it in detail. If you don't know this, then you're done. But you must know, usually this topic is going to be carrying around 7 marks. That 7 marks is very important. Like, you remember this module, if you get yeah, 100%, you are good to go. So the best way, I can say that the safest way in this module is when you are passing test one with good marks, because you don't know what's coming on test two, and you might not get test three. So you must be strategic, right? So now we come to definition. We look at the negation, right? Then for the negation, if we let P be any statement, then the negation of P is the statement that we can say that a response that P or not P. In other words, if P is true, the negation of P will be not true. You say right now, if P is true, the negation of P will be not true. So here it is very clear that if P is true, then negation of P is false, and vice versa, right? And also it means that if negation of P is false, or if negation of P is true, then this one must be false. So let's look at the table. It's always the opposite when you're negating, right? If this is true, its negation will be false. If this is false, its negation will be true. So negation is one of the simplest amongst all of these, right? But I believe that they're all simple. So now we come to constructing uh, a truth table. They say for this tutorial is there in the guide, right? I just took a tutorial. This is the first tutorial we come across. So we say that for problem statement, we must construct the truth table for the following statements. We have A, they say we must construct P or Q, or P or negation of Q and negation of Q. Also, they say we must construct B, C, and D. So what I'm going to do here right now, I'm going to construct uh, A. I'll construct A first, then I construct B. Then yourself, you're going to do C and D, right? So let's do that. It's P or negation of Q. It's P or negation of Q. P or negation of Q. So let me just use this one. It's fine. Or let me say this. P or negation of Q, right? Then we're going to construct that. And then we see where does it take us, right? So now for A, they say we must construct a P or negation of Q. I think it's and negation of Q, right? If I'm not mistaken, I'll check that. Let's see. Yeah, it's that, right? So we check here. How many statements are we given? Who can tell me how many statements do we have here? How many statements do we have? How many statements do we have? Two, right? Yes, P and Q, right? Yeah. So it means that since we have two, our formula says what? Two to the n, right? Ne? So since our formula says two to the n, we're going to plug that two. So n is equals to two. We say right ne? So this will be four. So since this is four, we're going to divide this into two. And then we know here we're going to have the two number of truths, two number of false. Then we divide this into one. We have true, false, true, false. So let's draw this. So we have P. First of all, before we think of any negations, we must draw our normal statements. You see right there. This is true, true, false, false. True, false, true, false. So like that. Now we check other statements that we have here. Do we have negation? Yeah, we only have the negation of Q. So we're gonna put the negation of Q. We're just going to put the negation of Q there. Then we check the statements that we have. We start with the ones inside the brackets. We have P or negation of Q inside the brackets first. P or negation of Q. Then all in all we have this or negation of Q, a close, and negation of Q. So for the negation of Q, remember negation of Q is the opposite of Q, right? So this will be zero. So let me input this 0, 1, 0, 1. So it's the opposite of this. You see right now. And the opposite of 1 is 0. The opposite of 0 is 1. So uh, now when we check P or Q, remember I said that this or we're gonna treat it as plus. So here we are adding P and the negation of Q, right? That means that when I add this, let's say what is 1 plus 0? 1, right? Now 1 plus 1, it's 1, right? Then 0 plus 0, it's 0. 0 plus 1, it's 1. So it means that when we come to this, right, we know that the truth value that we have here for this statement is 1101. So you must keep in mind here, 1 plus 1 is always 1, right? So even if we can add the three ones, remember this one is not a normal one, it's a truth value. So we're saying that true plus true will give us true. True plus true plus true plus true will still give us true. So now we say that for the last one, we are taking this and this. They say that that's what the statement is saying. And we say that for and, we're going to use multiplication. So 0 plus 1 will be 0. 0 times 1 will be 0. 1 times 1 will be 1. 0 times 0 will be 0. 1 times 1 will be 1. Then that will be the final statement for this one. So that will be the truth value for this statement. Any question? So you see, it's simple, right? Ne? Let's say they said 7 months. You just get your first 7 months here. So if there's no question, it's fine. Now, let's go look at B, right? I said that I'm going to do A and B, and then yourself, you're going to do the remaining. So for B, we are saying that we are given the negation of this first one, or negation of P and the negation of Q. So let's write that negation of P and negation of Q, or negation of P or negation of Q. So how many statements are we given here? Who can tell me how many statements do we have? How many statements do we have? P and Q, the two, right? We only have P and Q. So when we are going to copy this, we must first write P, Q. Already we know we're given two statements, and we know the truth value for two statements, right? We know how we write it. So we can always check when I'm writing this is how I should you say right now. We can always check that. So let me say this. We can always be checking those statements. So now let me just draw a table. Now we see. Now, yeah. So we're going to have then here we have negation of P, right, and negation of Q. So we can first put negation of P, and then we'll put negation of Q. We'll put negation of Q. So I'm going to start with the one that is in the set. According to alphabetical order, between Q and P, P comes first. So I'll start with, always I'll start with P. You don't just start with N, right? This should be in alphabetical order. So avoid, I know someone is going to get there and start with Q while they've never seen anywhere starting with Q, right? People like to write new things. They explore in the test room. So when we start with inside the brackets, we'll start with this one. So we have negation of P and negation of Q. And then we come to this one here inside the, remember we always start with the ones inside the brackets, right? Come with negation of P or negation of Q. And it's always good to start here if the brackets start on the left hand side. You see I have brackets this side and this side. Start here, go in that side. So now this side we have the negation of this. Remember this is negated. This one is not a negation, right? This is just P or yeah. Now remember this one is negated here. So we're also going to negate it. This is very important. The majority leave this out. I'll tell you that the majority they don't write this, they do it in their mind. They wanted the lecturer to guess that they wrote it in their mind, right? Then they come and write the one of the negation. So you must not be like that. And then here I'll just write A. You'll see why I do that, and you learn also to do that. So here, what I'm gonna do, right? I'm just going to say this is congruent to A. So if you want to replace a statement by a letter, you see that there's no longer space to put it. There's no space to put that statement, right? You just say it's congruent to a certain letter. Then you put it that letter there. You say, right, so I say that that is congruent to A. So we know that here is going to be 1, 1, 0, 0, 1, 0, 1, 0. We agree, right? The negation of Q will be the opposite of this. So this will be 0, 0, 1, 1. Then the negation of Q will be the opposite of Q. It will be like that. And then now here, we come and say that negation of P and the negation of Q. Now, we want to apply this. We want to apply a conjunction, right? We want to apply a conjunction, then we can apply multiplication. Remember, I said that a conjunction represents multiplication. So for negation of P, for these two, if we want to multiply them, we're going to say 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1. And then P or negation of Q, right? Now for P or negation of Q, remember that oh, it's a plus. So 1 plus 0 will be 1, 1 plus 1 will be 1, 0 plus 0 will be 0, then 1 plus 0 will be 1, right? Then now we check the negation of this. The negation of this will be 0, 0, 1, 0. Then now they say we must add this and this. When we add them, realize here we're going to get 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. So we're going to have 0, 0, 1, 1, right? Which is 0, 0, 1, 1. So that's the truth value for B. That's the truth value for B. So now, when we check here, if we try to, let's say we asked to check whether this is tautology, contradiction, or neither, right? We're going to say that this one is neither because it includes both false and true. Also, this one we're going to say that this is neither also. It includes both false and true. So you should do uh, C and D. You're going to try C and D. So let me just write here. You're going to try C and D. So yeah. So this is where we'll stop. Uh, Usually we still have a lot of time, right? But we can stop here so that you can process. The next time when we meet, we are doing lecture 2, which I've already sent there. You can also try to do it. For now, do C and D. And then I'll also send another problem slide where I'll just be taking questions from the previous question papers, which are based on this. And then I say write them, right? For now, do C and D so that when I give you those ones, you are able to keep up. So if you have any question, be sure, right, to send your questions to this number. Don't send it to the other one. Send it to this number. Let me show you. Because on the other side, I might not answer you, right? You must send to this number. So you must send it to this number, right? This one with this profile. So you must send to this one. And that's where I want your questions to be. I get you can say send the link with that number, right? So you must send here. So let me even just type. So you must make sure you send your solutions here. Let me, yeah, we can call it a day, guys. I'll share the recording in the group. Make sure that you subscribe there so that you can get the notification.